Looking back some 13 billion years, NASA's Hubble Space Telescope offers a glimpse of the early universe, revealing countless galaxies in a tiny area of sky. Galaxies are the visible foundation of the universe, each one a collection of stars, planets, gas, dust, and dark matter, held together by gravity. Hubble's observations give us insight into how galaxies form, grow, and evolve through time. Hubble's namesake, astronomer Edwin Hubble, pioneered the study of galaxies based simply on their appearance. He divided galaxies into three basic forms: ellipticals, spirals, and irregulars. Labeled the tuning fork diagram, Edwin Hubble's basic arrangement is still in use today. Elliptical galaxies are nearly spherical to egg-shaped groups of old stars that lack the gas and dust needed to form new stars. Rotation doesn't play a big part in their shape. The movements of their stars, often in long oval orbits, determines an elliptical shape. Elliptical galaxies are often near the center of galaxy clusters, suggesting they may form when galaxies merge. The best-known galaxies are spirals. The center of a spiral galaxy has a large, roughly spherical swarm of stars called a bulge. This bulge looks similar to an elliptical galaxy, but spirals differ from ellipticals because they rotate. Rotation gives spiral galaxies the flat disk that holds their spiral-shaped arms. Unlike ellipticals, spirals have a mix of young and old stars. Star formation in spirals is similar to a traffic jam on the interstate. Like cars on the highway, slower-moving matter in the spiral's disk creates a bottleneck, concentrating star-forming gas and dust along the inner part of their spiral arms. This traffic jam of matter can get so dense that it gravitationally collapses, creating new stars. Spiral galaxies are subdivided into unbarred and barred, and organized by the size of their central bulge and how tightly their arms are wound. Bars form in spiral galaxies when star orbits become unstable and stretched out. As their orbits lengthen, they create a bar. The bar grows as gravity captures more nearby stars. Irregular galaxies don't fit into one of the other categories. They are shapeless and have no symmetry or ordered structure. Irregulars may hold old and young stars, and often have knots of gas and dust forming new stars. Astronomers have expanded Edwin Hubble's basic tuning fork diagram to include galaxies that fall between his three categories. Intermediate spiral galaxies sit between unbarred and barred spirals, and have a small bar. Lenticular galaxies sit between elliptical galaxies and spirals. They have a central bulge of stars and a flattened disk, but no spiral arms. Like ellipticals, lenticular galaxies don't have much gas and dust, and also have mainly old stars. When viewed edge-on, their shape resembles a lens, which is why they're called lenticular. Edwin Hubble's tuning fork was a first step in understanding galaxies and how they evolve. Observations by the Hubble Space Telescope will continue to improve our understanding of galaxies and their role in the evolution of the universe.